Hello geometry, and welcome to the last lesson and last video of the school year. I hope that you are excited because I know I sure am. Okay, so we've covered surface area, which was the first half of chapter 12. We're now going to cover the last half of chapter 12, which is volume. With surface area, I broke it up into 2 videos. With volume, I'm going to get it all done in one. I think volume is typically for students easier than surface area is, and most students like it better. So I think we can get all of these shapes done at one time. So we're going to start by talking about prisms, which is what we started with when we did surface area. Remember, a prism means that you have 2 bases. Those bases are congruent and they are parallel. They could be lots of shapes. They could be triangles, they could be trapezoids, they could be rectangles, whatever. Remember, the way that we name a prism is based on the shape of its base. So for this first example that we're looking at, it's a triangular prism because the bases are triangles. So the formula that we have is V equals capital B times H. The good news is you already know what capital B is because it was the same thing with the surface area formulas. Capital B stands for the area of the base. So this is where you have to know areas of formulas for areas of triangles, for rectangles, for trapezoids, whatever that shape is, you have to know it. And we've been learning those all year. So you've got to still remember those. H, you guys already know what H is. It's the height of the prism. Again, remember what I said when we did surface area. The height of the prism means the distance between the bases. How far apart are the bases? That's what you need to know for H. So let's take a look at example number 1. I'm going to start by just writing down the formula, and then I'm going to go off to the side and do a little bit of work. I'm going to start with capital B. So we already identified the fact that our bases are triangles. How do I find the area of a triangle? That's easy. 1/2 times base times height. Now this H is not the same thing as this H because these are 2 different formulas. This H refers to the height of the prism. This H is finding the area of the triangle, and that means the height of the triangle. So don't get those confused. Whatever you use over here for H doesn't mean that's going to be the same number over here. So that's why you have to understand what it is that you're solving for. So remember, when we are trying to find the area of a triangle, remember that's what this formula is representing. Your base and your height always have to be the 2 sides that form a right angle. So looking at this picture, these 2 sides are going to be the 2 sides that form a right angle. And that's where I have a little bit of an issue, right? Because I know one of the sides, but I don't know that one. However, I do know the hypotenuse. So this leads me to automatically thinking about the Pythagorean theorem. So I know one of the legs is 12. I'm missing the other leg. Now you can use a variable. You don't have to use a question mark, whatever you want. And I'm going to set that equal to the hypotenuse squared. So 12 squared is 144. 15 squared is 225. I'm going to get rid of the 144 using subtraction. So now I have my missing side squared is equal to 81. And when I square root each side, and I don't think about plus or minus because I can't have a length that's negative, I'm going to get that my missing side is 9. So this missing side is 9. So I'm going to come back over here and say, okay, now I can find the area of the triangle because the base and the height are the 2 sides that make up the right angle, and that's the 9 and the 12. So 1/2 times 9 times 12 is 54. Hopefully everybody feels okay with just finding the area of a triangle. All right. Now let's talk about, first of all, let's plug that in. That's a 54. And now let's talk about H. Remember, in this formula, the H doesn't mean the height of the triangle. It means the height of the prism. In other words, how far apart are the 2 bases? In this case, how far apart is the top from the bottom? And that's right here, 10 centimeters. So I'm gonna plug in a 10. So 54 times 10 is 540. I need units. Those are gonna be centimeters, but for volume, volume is you're filling the box or whatever the shape is. So with surface area, we did everything squared. You were covering the surfaces. You were finding area. But with volume, you're taking that three-dimensional figure and you're essentially saying, how much do I need to fill it up? And so that is going to cube your units. So 540 cubic centimeters is the answer for the volume. Pretty easy, right? All right, so example number 2 says, find the cubic feet of, what is my computer doing? Sorry, got weird stuff going on back here. All right, find the cubic feet of cement that are for a 60-foot long driveway that is 9 inches thick and 20 feet wide. So right here when it says find the cubic feet, that right there is my clue that I'm looking for volume. How do I know that? Because I have a unit that's being cubed. That's what I just said a minute ago, right? When you deal with your units for volume, you're going to cube them. So I'm looking for volume. That's what this is saying. Now I'm going to draw a picture, and not everybody in our class needs a picture, but I'm a visual person, so I'm going to draw one anyway. So we have a driveway, and it is 60 feet long and 20 feet wide, and it has a thickness of 9 inches. How's everybody doing? Okay, there's my picture. Now, let's talk about this, because right away I hope that you're noticing that these have the same units, but here's the problem. This is a different unit. So right away, I need to change them all to be the same thing. Now, again, let's go back to the directions. It says find the cubic feet. That means we want everything in terms of feet. So let's talk about 9 inches. 9 inches. Well, what do you know about a foot? A foot has 12 inches. So 9 inches out of 12 inches, the inches are going to cancel. 9 over 12 reduces, and we're going to change that measurement of 9 inches to 3/4 of a foot. Or if you like decimals, you can put 0.75. That is entirely up to you. Now let's talk about our formula. Volume equals capital B times H. Let's talk about capital B. Remember, capital B means the area of the base. Okay, so I'm looking at this driveway that I have drawn, and to me, the top and the bottom are going to be the bases, okay? That's what I'm going to choose for my base, and that is a rectangle. So how do I find the area of a rectangle? Well, you can either do base times height, or you can do length times width. They mean the same thing. So base times height or length times width, either way is going to get 60 times 20, which is equal to a whopping 1,200. So I get to plug in 1,200 for capital B. Now, little h, remember that means the height of the prism. How far apart is the top base from the bottom base? And that's going to be that number right there, 3/4, or you might have 0.75. I like fractions better because I can do this in my head. What is 3/4 of 1,200? That's easy. 900 and feet cubed, because we needed it in cubic feet. So there's our answer for example number 2. See, volume really is, I think, easier than surface area. All right, so next example says to resurface a football field, it was dug 6 inches deep. How many cubic feet of dirt are necessary to fill the field? A football field is 65 yards wide and 120 yards long. Okay, so just gonna do a rough sketch. Not gonna make it real pretty because I don't ever, do I? Okay, so there's my football field. All right, so what do we know about the football field? It's 65 yards wide, so 65 yards wide and 120 yards long, okay? And then it is 6 inches deep. So real quick, remember in the last problem we said everything needed to be the same units. And so last time we changed the 6 inches. Well, in the problem, again, this key phrase, it says how many cubic feet. This tells me that everything needs to be in feet. Not just this number, but those two numbers as well. So I'm gonna start with this number because it's easy. 6 inches, all right? Well, again, just like the last problem, 6 inches out of 12 inches, inches cancel out, 6 over 12 reduces. We're gonna turn that into a half a foot. And if you like decimals, change it to 0.5. Now let's talk about yards. What do you guys remember about yards? 1 yard is equal to 3 feet. So how do we change 120 yards to feet? Well, that's easy. We're just going to multiply by 3. So this turns into 360 feet. And then we're going to do the same thing for the 65 yards. We're going to multiply it by 3, and that's going to turn into 195 feet. So we now have everything changed to the proper units. So here's my formula. Let's talk about capital B. Again, that means area of the base, which is a rectangle. So we're either using base times height or length times width. It doesn't matter which one you choose because either way we're going to do 360 times 195. And why don't we use a calculator? 360 times 195 is going to give us 70,200. So there is the capital B. Now we need to identify the H. Again, that means height of the prism. What's the distance between the two bases? And that is a half a foot. So I'm going to take my 70,200. I'm going to multiply by a half, and half of that is 35,100 feet cubed. That is how much dirt you would need to cover that football field. All right, example number 4. This is a good one because this is a real life example. It says a farm feeds its cows using a trapezoidal trough. So right away they're letting you know the bases are trapezoids. Find the maximum volume in square feet of the trough with the indicated measures below. So we've got numbers here. Okay, so first let me write down the formula, right? And look at what we have in the picture. We have 8 feet here. We have 18 inches, 10 inches, 12 inches, and the key phrase is find the maximum volume in square feet. That means we need all of our units to be in feet, not inches. So we're gonna do what we've been doing in the last couple of problems. I'm gonna start right here with the 10 inches. So 10 inches out of a total of 12 inches, right? Because every foot has 12 inches. Again, inches cross out. 10 over 12 reduces to 5 over 6. So that value down there is 5/6 of a foot. Now for those of you that like decimals, don't do it because that's going to be a repeating decimal, which you would have to round, and then that's going to change your answer later. So we don't want to round a number this early in the problem, so leave it a fraction. All right, let's come over here. 12 inches. I really hope y'all think that one's easy because 12 inches is exactly 1 foot. And then the last one we have is this 18 inches right here. So 18 inches, again, out of 12 inches. Inches cancel out. 18 over 12 reduces to 3/2 feet. And I'm writing that. I want to draw an arrow because it's kind of hard to see it on the picture. So 3/2. There we go. Okay. So first we're going to start with capital B. Remember, capital B stands for the area of the base. We are dealing with bases that are trapezoids. I can see that in the picture. I can also see that in the way that they worded the problem. They told us that. So how do we find the area of a trapezoid? Well, if you remember the trapezoid song we learned, trap, trap, trapezoid, base 1 plus base 2, multiply by the height, then divide by 2. You can do it that way, or if you know the formula, which I happen to know, probably comes with being a math teacher. So there's our formula, okay? So let's look at what we have. 1/2. All right, let's talk about h. So h is the height of the trapezoid, not the height of the prism, the height of the trapezoid, which is right here, y'all. That right there was 12 inches, and remember we changed it to a foot. So the height is 1 foot. All right, then we're gonna have base 1 plus base 2. So remember with trapezoids, the bases are the two sides that are parallel. In that case, that's this top side right here and this bottom one right here. Now remember, this one we said is 3/2, and this one we said is 5/6. So 3/2 and 5/6. Does it matter which one goes first? No, you can put them in any order that you want. All right, let's go ahead and take care of this. What is 1/2 times 1? That's easy, 1/2. Inside the parentheses, because I want to work inside the parentheses because order of operations tells me to do that first. I need a common denominator if I want to add those fractions, and that common denominator is 6. So 5/6 is good as is, but 3/2 is going to turn into 9/6. So when I add those fractions together, 9/6 plus 5/6 is 14/6. We're going to take that 14/6 and multiply it times 1/2. Now I can already tell you I can cross cancel because 2 goes into 14 7 times. So now capital B, I get an answer of 7/6. Okay, so all of that was a great review of trapezoids. So let's come back to our volume formula. In place of capital B, we're going to put 7/6. Now we need to look for h. Remember, h in this formula is the height of the prism, which means the distance between the two bases. So what's the distance between those two trapezoids? And that distance is right here. It is 8 feet. Now if you want, you can put that 8/1. Again, I can cross cancel because 6 and 8 are both divisible by 2. So the 6 is going to turn into 3. The 8 is going to turn into 4. And now when you multiply fractions, you multiply straight across. So 7 times 4 is 28 for the numerator. 3 times 1 is 3 for the denominator. And I need units, which are cubic feet. Ta-da! There we go. All right, so we just spent a lot of time there on prisms. Let's talk about cylinders, because remember, a cylinder is like a prism, right? Remember that formula again that we've been using? Capital B times H. Well, capital B means the area of the base, but with a cylinder, your base is a circle. And that's where the pi r squared came from. That's how you find the area of a circle. So we're still using this formula. They've just already plugged in the pi r squared in place of the capital B. So you can stick with this formula. That's going to be easy. So here we go. Example number 5. Find the volume of the right cylinder and round to the nearest tenth. So we will definitely have to use a calculator here. So I'm going to start by just writing down the formula. These are quite nice because you're just going to plug in what you got. So radius, they tell us, is 3.2. Height, that means how high was the distance from circular base to circular base. Well, that's easy. That's this 10.5. And here comes a really easy part. We're going to use our calculators. This is going to work out that index finger right there. All right, so we have pi times 3.2. Oh, come on. Well, yeah, squared times 10.5. All right, so I'm plugging it into the calculator just like I have it on my paper. And we're gonna round to the nearest tenths place. So the 8 here tells us to bump that 7 up to an 8. So we're gonna have 337.8. And again, because we are rounding, we're gonna use an approximate symbol. So approximately 337.8 centimeters cubed. Done and done. Okay, example 6. Same formula. So let's see what we've got. Pi times the radius. Okay, look at the picture. They gave us all the way across the diameter. How do we find the radius? You chop it in half. So what is half of 8? That is 4. So we have our radius. Now we need the height. Ooh, this is a really good problem. So this line right here represents the height, and we don't know it. But look at your shape. We have a right triangle, which automatically tells me we are using the Pythagorean theorem. Hopefully you've noticed we've been using that a lot in this chapter, right? We have used it all the way since, I want to say chapter 1, but I don't know if that's accurate. We've used it for a long time. So moving that 64 over, and that's gonna leave us with, let's see, yeah, 225. Ooh, good news. That is a perfect square, and we now get a height of 15. All right, so they didn't give us everything we needed to plug in, but we were able to easily find what we did need, and now I'm gonna use a calculator. So pi times 4 squared times 15. Again, just plug it into your calculator like you see it. Oh, I have it in math print. Okay, hold on. Now, if this were a test, I would typically, if the directions didn't say to round it to the nearest tenth, I would have no problem with you leaving it as that and include those units. But here it told us to round it. So let me get this thing out of math print. Bum, bum, bum. Classic. All right, try it again. 240 pi. Okay, so rounded to the nearest tenth. The 8 is going to bump that up, which in turn bumps that up. So we're going to have 754.0. So approximately 754.0 feet cubed. Easy peasy. Okay, so now let's talk about cones and pyramids. Okay, there is only one difference to the formula. You now have a 1/3 in front of it. So this goes for cones and pyramids. Let me tell you why. If you had this right here and your base was still this, but let's say it instead of a pyramid you had a prism, so you had a box. Okay, 21 is still the same, this base is still the same, you just had another base at the top. It would take you 3 of these pyramids to fill up that box. This pyramid is 1/3 of what that box would be. That's where the 1/3 came from. So that's your formula. Now for the cone, if you want, you can go ahead and fill in the capital B with the pi r squared, right? So basically you're taking your cylinder formula and you're dividing it by 3. Here we're taking our prism formula and dividing it by 3. And so for some of you, maybe that is more comfortable. Maybe you want to think about it that way. Same thing here. Maybe you feel more comfortable with thinking about it as dividing by 3 instead of multiplying by 1/3. They mean the same thing. Do what you think feels the best. All right, so example number 7, here we go. Find the volume of a right circular cone with a radius of 5 centimeters and a height of 9 centimeters, and round your answer to the nearest tenth. So I'm gonna go ahead and write the formula down. And I think they gave us everything. So we got 1/3 pi. They tell us that the radius is 5. And they've told us that the height is 9. So let me go ahead and change 5 squared into 25. All right, guess what? The 3 in the denominator can cancel with the 9. It's going to turn that 9 into a 3. So right now, before I use a calculator, I'm going to have 1 times 25 times 3, which is 75 pi. But again, the direction said round it to the nearest tenth. So 75 pi is 235.6. So my volume is approximately 235.6. I need my units. Centimeters cubed. Isn't that easy? Yes, it is. Okay, so now let's look at the next one. Again, we're finding the volume. This is a pyramid. So here's our formula, 1/2 times capital B times H. All right, so off to the side, I'm gonna talk about capital B. The base is a rectangle. How do I find area of a rectangle? Base times height or length times width. Either way, we're gonna do 12 times 10, which makes capital B 120. So I have 1/3 times 120. Now I need H. H in this formula means the height of the pyramid, which is right there, 21 centimeters. So 3 can cancel into 21 7 times. I'm left with 120 times 7, which is 840. I need units. They are centimeters cubed. These are easy. All right, let's try one that is a little more challenging. And by that, I don't mean hard. I just mean it brings back some trig, because Miss Wingard loves trig. All right, so find the volume of the solid. So formula, 1/3 times pi times r squared times h. Okay, so what do they give us? Well, the 6 feet refers to the h. So we have the h. What is it that we don't know? We don't know the r. However, they gave us an angle measure right here of 42 degrees. Now, what do you know about this angle? Well, it has to be a right angle. So what shape do you have? You have a right triangle. And if you have a right triangle, you can use trig. So we're going to go back to SOHCAHTOA. All right, so we're looking at this angle, which is 42 degrees. Remember the words that we talked about with SOHCAHTOA. Those are opposite, adjacent, and hypotenuse. So from this angle right here, what word would we use to describe the 6 feet? It would be opposite. So that is opposite. Now we're trying to find the radius. What word would you use to describe that leg? That would be adjacent. So we have opposite and adjacent. Which trig function is going to work? That is going to be TOA. So we've got tangent of 42 degrees equals opposite, which is 6, over adjacent, which is r. Now remember, the first thing that we always do is we multiply by whatever is in the denominator. In this case, that's a r. So I'm going to multiply both sides by r. So I have r times tangent of 42 degrees equals 6. Now I want to get r by itself. That means tangent of 42 degrees needs to go away. How are they joined together? Multiplication. How shall I get rid of it? Division. So I'm going to divide both sides by tangent of 42 degrees. All right, so we now have r by itself. And once you have r by itself, this is when we get to use the calculator. I'm going to go ahead and put an approximate sign because I know it's going to come out to be a crazy decimal. Let me check my calculator, make sure it's in degrees, and it is. Yours probably is already in degrees, but for pre-cal, I go back and forth from degrees to radians, so I needed to check that. So I'm going to do 6 divided by tangent of 42 degrees. And we're gonna round it to the 10th place. So this is, these are fun digits. We're gonna say that that is approximately 6.7. Now, let's come back over here and use our formula. Now I will go ahead and tell you, I'm gonna go ahead and put approximate. Why am I putting approximate? Well, I'm already using a rounded number to plug into the formula, so it's already gonna be approximate and not exact. Plugging in the 6.7 for the radius. We said that the height of this cone is 6 feet, and now I'm gonna use the calculator. So I have 1/3 times pi times 6.7 squared times 6. All right, plugging it in, and we're gonna again round it to the nearest 10th place. So I've got 282.1 approximately 282.1 units feet cubed. So that was not a hard problem. We just had a good reminder of the end of chapter 9. All right, example 10. This is a pyramid. So our formula is 1/3 BH. All right, let's talk about capital B. That stands for the area of the base. Our base is a triangle. How do we find the area of a triangle? 1/2 base times height. Remember, this height doesn't mean the height of the prism, it means the height of that triangle. And remember, your base and your height always have to form a right angle. So looking at this triangle right here, the 12 and the 9 form the right angle, and we are gonna get 54 for capital B. So I have 1/3 times 54. Now H, I need, what is the height of the pyramid? Right there, 13 inches. All right, I'm gonna start by cross canceling because 3 can go into 54 18 times, and 18 times 13 is 234, and my units are inches cubed. So that one was also a pretty easy problem. Okay, so last thing we're going to talk about is the volume of a sphere. We already learned that the surface area of a sphere is 4 pi r cubed. The volume of a sphere is 4/3 pi. No, I don't know what I just said a minute ago. I hope I said 4 pi r squared for surface area, but I kind of think I said the wrong thing. But for volume, we're going to do 4/3 pi r cubed. So find the volume of the sphere. So I got 4/3 pi r. What's the radius? It's 18. And we're going to cube it. And we're going to use a calculator. So 4/3 pi r, so 18 cubed. So we're raising it to the 3rd power. And this is a huge number. So we're going to get 24,429.0 centimeters cubed. Ta-da! Super easy. About to run out of lead. Okay, so last problem. Can you feel the excitement? This is the last example of the year. And also why I made it challenging, because it's more fun. Okay, water tower. We have a water tower. So that's the water tower. And then they drew a picture for us that gives you like the flat model of what that would look like, all right? Made up of 3 different shapes. So at the top you have a cone, in the middle you have a cylinder, and at the bottom you have half a sphere, otherwise known as a hemisphere. And hopefully y'all recognize that word. That is a social studies word. Okay, so we are being asked to find the volume. So we have a cone at the top. We have a cylinder in the middle, and we have a hemisphere at the bottom. So we're gonna take it step by step. We're gonna find the volume of each, and then we'll be able to add them together to get the total volume. So that is the plan of action that we're doing. So let's start with the cone. We know our formula is 1/3 pi r squared h. Okay, so looking at that cone, let's see, what have we got? Well, ooh, look, see this one makes you think a little bit. So we have an angle measure, right? Which doesn't quite help us out yet. We have this number right here, 25 feet. Well, that helps us with the cylinder. We have this number right here, 8.5 feet. Here's what I want to talk about. What does that 8.5 feet represent? It represents this dotted line right here. What does that dotted line represent in the hemisphere? It represents the radius. Now, remember that a radius, hang on, I'm having a brain freeze for a second. Where was I going with this? This is why you don't do videos late at night, because sometimes you lose your mind and you have no idea what you're talking about. What was I getting ready to say about the radius? Gee, Manetti. Complete silence because my brain is frozen. Oh, I know where I was headed with this. Duh. Sorry, y'all. Radius. Okay, remember the radius. It goes from the center of the circle, in this case, the center of the sphere, right? Well, so from here, because this would be the center, to A represents a radius. But guess what? From here to B also represents a radius. And from here to K also represents a radius. And once you know the radius, it is not going to change. So that means from C to B is also 8.5. From C to K is also 8.5. Now you might be wondering, how does that help us? Because we're talking about the cone. I'm so glad you asked. Because this is like a rectangle, right? When you look at it flat. So that means that whatever this side is as well. So from F to D is 8.5, and from D to G is also 8.5. Okay, now we're making some sense. All right, so looking at this picture, we know the radius of the cone right there, 8.5. So I've got 1/3 pi. Radius is 8.5. We're going to square that, and now we get to H. And guess what? That's this line right here from E to D. And they didn't give it to us. However, they gave us that piece of information right there. We have an angle measure of 47 degrees. So this is going to bring some trig back, right? SOHCAHTOA. SOHCAHTOA. Okay, so in this right triangle, from the 47 degree angle, what word would you use to describe the 8.5? That would be adjacent. What word would you use to describe the H? That would be opposite. Which trig function uses those two words? Tangent. So I've got tangent of 47 degrees is equal to opposite, which is H, over adjacent, which is 8.5. And just like we did earlier, first thing you want to do is get rid of the denominator. So I'm going to multiply both sides by 8.5, which allows us to get H by itself. So this is what I get to plug into the calculator. So here we go. I'm going to do 8.5 times tangent of 47 degrees. We're going to round it to the nearest tenths place. So that's going to be 9.1. So H for the cone is 9.1. So I'm going to plug in a 9.1 right there. All right, so let's plug this in. So we got 1/3 times pi times 8.5 squared times 9.1. So we've plugged in the radius and the height of the cone. We're going to round it to the nearest tenths place, so we're going to get 688.5. Okay, so far we have the cone. Now let's go to the cylinder. So the cylinder's formula is pi r squared h. It gets rid of the 1/3 because it has two bases, not just one base. All right, so according to the picture of the cone, not the cone, the cylinder, the radius is still 8.5, right? 8.5. The height is this number right here. It is that 25 feet is the height of that cylinder. Ooh, don't let me forget that squared. Okay, so we're gonna plug that into the calculator. So we have pi times the radius, which is still 8.5 squared, times the height of the cylinder, which was 25 feet. And so we're gonna get 5,674.5. 5,674.5. Okay, last part here, hemisphere. Okay, well, remember what we learned about the sphere. Ooh, right there. The sphere is 4/3 pi r cubed. But what do you know about a hemisphere? A hemisphere is only half of a sphere. So I'm going to take that formula and multiply it by half. Does that make sense? Because we have this as the formula for a whole entire sphere, but we only want half of it. So one thing I know is that 2 can cross cancel with 4 and become a 2. So my fraction is now 2/3 pi. We're going to plug in the radius. We already talked about that, right? It was 8.5. And we're going to cube that. So calculator, here we come. We have 2/3 times pi times 8.5 cubed. Do I have it plugged in right? I think so. So we get 1,286.2. So volume 1,286.2. Okay, so for the total volume, we're going to take the 688.5, the 5,674.5, and the 1,286.2. We're going to add all of those together. So we're taking the cone at the top, the cylinder in the middle, and the hemisphere at the bottom, and we're adding them all together, and we're going to get 7,649. Oh my goodness. I need a break here. Volume is 7,649.2. What are our units? Where am I? Feet. Feet cubed. That is how much water can fit into that water tower. It's a lot of water. All right, y'all, it has been a pleasure to teach y'all this year. I'm sad that the year is ending in the way that it is, and I never got to bring y'all cupcakes. I was planning to in the spring, and of course, look what happened. Way to go, coronavirus. But it really has been a pleasure to teach y'all, even on the days when y'all would drive me a little bit batty. Still love y'all, and hope to see all of you next year for another math class. See you later.